All right, good morning, everybody. So I actually changed the title of my talk because I thought we needed more cool sci-fi references. So this is Building a Better Wormhole. And, so a wormhole in physics, right, is a hypothetical way to, create this connection between widely separated regions of space and time. So there's been some great movies about this, Stargate, movie about traveling to alien civilizations by stepping into this wormhole, or Interstellar, where after the world becomes uninhabitable, mankind can use a wormhole to find a new place to call home. I want to talk about one of my favorite wormholes, which is a way that you can bring strange and distant browsers to your local environment in the middle of a painful debugging session. So. Before we get into that, just a little bit about me. So I'm Dave. I'm a site reliability architect at DNAnexus. That's one of the hats that I wear, even though I'm clearly wearing only one hat in this picture. I wear two hats. My first hat as a site reliability engineer, I'm testing scalability and reliability for the DNAnexus platform. And we're a cloud-based platform for analyzing massive amounts of DNA sequencing data. And so basically, we're going after helping biopharmaceutical companies and leading genome centers to accelerate the pursuit of precision medicine, trying to find cures for nasty diseases by looking at clues within our own DNA. And we are hiring, so check out our website if you're interested in that kind of thing. My other hat is that I'm a co-founder and maintainer of Test Armada, which is a suite of tools for doing massive scale test automation and making it work within a large distributed development environment. So this was something that was heavily sponsored by Walmart, but is used by a lot of other companies as well. Now, what we're going to learn about today is our favorite wormhole, Sauce Connect, how to keep it secure, how to ensure that it is not only secure but reliable at scale. There was a great question in the last talk about how do I know if my Sauce Connect tunnel goes down, and what do I do about that? And using some open source tools to do some of that heavy lifting for you. So just a quick overview of how this wormhole works. So on the right side here, we've got the Sauce Labs cloud. They're running all of these browsers and devices so that we don't have to worry about maintaining this farm of browsers. And they create this magical tunnel, this wormhole, into your own network. And that big circle on the left side is the Sauce Connect client. That's where the wormhole opens up and everything can travel in and out. And this is just so convenient, right? Because you can test your local host, you can test an internal staging server that is not exposed to the internet. You don't have to worry about all these pesky things like firewall rules and information security people, because you can just open up a wormhole wherever you want, and Sauce Labs can get through and test whatever you want to test. So that is great, right? How many people here use Sauce Connect regularly? Show of hands. Okay, great. And how many people feel totally confident that your Sauce Connect setup as you use it is secure? Okay, I think maybe like a little like wishy-washy wavy hand. So hey, I was in that boat too, and I'm going to tell you about how we improved that confidence. So I think it's an important thing in software to talk about convenience versus security. So how many people regularly use the terminal on their computer and copy paste things like on the top there into their terminal without really giving it a second thought? Okay, I do, so it's okay. You can raise your hand too. This is called a curl bash statement. So at the end, we're basically downloading a file from the internet, maybe from a reputable open source project, whatever, and we're using that little vertical line there, that pipe command, and sending it to bash. So we're basically taking the contents of a remote file that maybe we didn't even look at, and we're executing it and running it on our own computer. It's convenient. It's a good way to install a program without running a whole lot of separate install scripts. But you're trusting that you're taking security out of your own hands and putting it into somebody else's. Similarly, when we run our Sauce Connect client here at the bottom, we're doing a similar thing. We're opening up a wormhole into our local network, bypassing all of our information security so that we can test something on another browser. It's easy, but we have to think about security, right? So Sauce Connect does offer a lot of built-in security. They've done a fantastic job making it secure. It uses TLS encryption so that nobody can spy on your traffic going back and forth. That is all encrypted. connects to disposable VMs so that nobody can look and see a trace of an artifact of a test that's been run. And no need to think about security, right? Because those things are pretty good, and yeah, everything else, we just won't worry about that. So not quite, right? There are some other things we have to think about when it comes to security. And to give you an example of why, let's play a game of what do these things have in common? Target, Netflix, and Lady Gaga. Anybody have any guesses? They were born that way. Awesome, I love that. That is true. Also, they were all hacked by, not directly, but through their vendors. So there was a New York Times article that just came out a few weeks ago that the vast majority of data breaches, over 80% by some estimates, stem from a supplier or a vendor. So should we all freak out and bring everything in-house and stop using vendors? Obviously not, right? This would bring all progress down to a halt. We can't do that, but what we can do is be smart about it. So let's look into how this stuff kind of happens. So with Netflix recently, a hacker broke in and stole season 5 of Orange is the New Black, right? And they put up a ransom to try to get Netflix to pay to prevent them from leaking it. Netflix said no way. It got leaked onto BitTorrent. And the source of the leak appears to have been a security breach at an audio post-production company. So somebody found the weakest link. This company had lax security, and they were able to get a hold of the episodes that way. With Lady Gaga, somebody sent a very convincing email to one of their music management businesses and allowed them to get a hold of all of these stem files, which are used for remixing and remastering. So this wasn't even a technical hack, it was a social engineering hack. And with Target, this was a really prominent one a few years ago. Up to 110 million customers' credit cards were stolen. And it turns out that this came through a refrigerator vendor. So Target had a company that was allowed them to remotely access refrigerators in their Target stores. And as part of that, they gave them access to the internal company network, starting to sound familiar, so that they could monitor those refrigerators. But the hackers were able to get in through that vendor and subsequently leapfrog onto the company's payment systems, download all your credit cards, and ruin Black Friday sales for Target. So in this kind of leapfrog attack, we have to consider this with Sauce Connect. No matter how good Sauce Labs security is, even if Sauce Labs themselves never gets hacked, even if they have excellent security, what if a hacker someday found a Post-it note on one of your employees' desks that had their Sauce Labs username and password, and they logged in and they saw there was an established tunnel, and they opened up a browser, used that tunnel to pop out of the other side of that wormhole where that Sauce Connect tunnel has access to your entire network. They log on to your company's payment system and hack you that way, right? So this could happen without Sauce Labs having any security problems themselves, right? This is just an issue of really thinking about what the end of that wormhole leads to inside your company network. So you can think about it like this, right? You've got this cat door. You think, okay, only the cat is ever going to go in and out of this, right? But then one day, look, like somebody else figures out how to get in. So so what if this raccoon is like a hacker, and your house is like your company network here, and this cat door is like a tunnel that you thought was secure, but it was not. And let's say that this cat food here is your company's sensitive payroll system, and you're like, only the cat has access to this. Like, no, there's no way a raccoon would even know like where to go. But look, there it is, right? So what do we do about this? Hope is not a strategy is one of my favorite sayings. This comes from Google's Site Reliability Engineering book. And hoping that your company isn't attractive to hackers, or that they wouldn't know what to do once they got into your network, is just not an effective way to think about information security. And I've had a lot of great chats with some really fantastic information security people in my career. And the truth is, they get paid to be paranoid. They're very good at it. And they have a default assumption that they can't trust things that they can't control. So third-party vendors immediately sets off red flags with Infosec. It's like, we don't know them. We don't know how their Infosec teams work. We can't control it, so we don't trust it, right? And I want to let you in on a little secret. The best way to get Infosec on your side is not to convince them to trust your vendors. It's to convince them that you don't even have to trust your vendors. That even if the vendor were completely hacked, even if they had the worst security policies, that it wouldn't matter, because even if they were compromised, that your company network is safe. So how do we do that? And we have to play defense in order to do that. And this is not a new concept. In fact, this is documented on the Sauce Labs website with their best practices, but it's just something that, unless somebody's kind of hitting you over the head with a hammer saying, hey, this is important, it's probably not something that you're going to think about because it's not convenient, but it's necessary. So what you have to do to make Sauce Connect secure is to set up what's called a DMZ, or a demilitarized zone. And so in computer networking, a DMZ is a subnetwork that contains and exposes an organization's external-facing services to an untrusted network, usually a larger network such as the internet. Does this mean that we don't trust Sauce Labs? No. This means that we're telling our Infosec people, you don't have to trust Sauce Labs because we're creating this network as if we don't trust what's on the other side. The notion of a DMZ comes from this geopolitical notion of setting up a buffer or an actual demilitarized zone between two hostile nations. So there's a famous DMZ between North Korea and South Korea where they're saying, okay, this is a buffer, nobody owns this land, nobody's going to do anything crazy on this land. It's not quite as safe as being on your home turf, but it's not quite as dangerous as crossing over enemy lines. Similar concept here in network security. So here's what it looks like. These two green boxes in the middle here are two firewalls. One is protecting traffic that is destined for the internet. The other is protecting traffic that is destined for your internal intranet, your local area network. And then trapped in between those is your DMZ zone. And so what we want to do here is create a DMZ zone in our network that houses a server that is running Sauce Connect. And the only servers that are allowed to run Sauce Connect have to be located in this DMZ zone where they have a double firewall controlling what can go out and what can go into your network. So these are things that are also documented on the Sauce Labs website. From the DMZ server out to the internet, you have to allow connections to Sauce Labs itself, of course, so you can talk to the API, as we learned in Leah's last talk there. We have to be able to allow connections to these Maki, Miso. I never quite understood what these naming conventions are, something cute, but Maki, XXXX, there's a bunch of different numbers there. These are the Sauce Connect tunnel servers that we're connecting to establish tunnels. And from the DMZ host into your internal local area network, this is the most important rule: deny all, deny everything by default. So unless it's explicitly whitelisted, Sauce Connect is not allowed to talk to it. So you don't want to do a blacklist thing. You don't want to blacklist only your payment system, only your internal GitHub. You want to deny everything unless it is explicitly allowed by a whitelist and classified as a system under test. So this way you're saying that only these things are allowed to be talked to from Sauce Labs, from Sauce Connect. And this one's kind of controversial. This is one that, to get the maximum security, you should also set up a rule from your local area network to the outside to deny connections to Sauce Labs. And this is going to make things really inconvenient because this means that people just can't decide, hey, I want to open up a tunnel ad hoc and test something. But unless you do this, there's always going to be a slight security risk that somebody could compromise just an ad hoc tunnel that somebody was running. So really what you want to do is say, hey, if you want to use Sauce Connect, you have to go through one of these persistent tunnels that's running on a dedicated DMZ server. And our goal is not to prevent ourselves from being hacked completely, but it's to reduce the attack surface. So this is something that our Infosec people over the years have taught me a lot about, right? Sometimes you can't prevent things, but you can reduce the surface. And in our little raccoon example, this means, hey, the raccoon gets through the cat door, but instead of finding himself with the free reign of the house to eat all the cat food, chew up your couch, all that stuff, he gets through the cat door, and he's trapped in this little cage with just some uninteresting things to him, and then he's like, okay, I'm just going to peace out of here. So, maybe in this case, a hacker, compromises one of your tunnels, and they can see your pre-production staging server. They can see a version of your website that's destined to go to production in a couple weeks anyway. No big deal, right? They're not going to compromise your payment system like Target. So great, we've averted this security risk, but we've made things a lot more complicated. And I showed you, some things about the firewall rules you have to set up. I'm not going to lie to you and say that that's as complicated as it gets, because we've hit a lot of other roadblocks along the way, speed bumps with the DMZ. So I just wanted to give you some lessons learned about some other problems and solutions that we've found to some of these things. So another one is whoever writes some Selenium tests and has Selenium open up a page on localhost. So this is really common if you're testing something on your local machine, or if you're testing something in a build but you're spinning up a mock server instead of actually deploying something to a persistent server. Super convenient, right? And in cases like this, what I used to do and what a lot of people do is they just run sauce connect right on the same box as the system under test, and that way localhost literally means the host that I'm testing, right? And so when a remote Sauce Labs VM uses a tunnel, pops out of the tunnel, and is literally on that same server, it's like, oh, localhost, no problem. That's me. That's where my server is running. But now, when you've said that your Sauce Connect client can only run in a separate DMZ box, and then the test is talking about localhost, things get a little confusing, right? Because the remote browser says, hey, I want to access localhost. The DMZ box says, hey, I'm not running a system under test on myself here. And then your poor little system under test is over there saying, hey, I'm over here, talk to me. But there's no way to get to it, right? So in the past, we've had to go through some kind of tedious processes to refactor our tests to actually reference a specific host name. For instance, instead of calling it localhost, call it staging 1. And that way, the DMZ can properly route the traffic to the right server. Another problem, this comes from the Sauce Connect docs here too, is increased latency, right? So let's say that these servers on the top here are in your San Jose data center, the servers on the bottom are in your Chicago data center, and you've set up a DMZ in San Jose, right? So Sauce Labs is going to go through the internet, tunnel into your DMZ proxy in San Jose. That proxy is going to say, oh, okay, you want to talk to our Chicago staging server. That means I have to go back out through the internet and back into the Chicago data center. So you're introducing a lot of extra hops geographically, right? And we know that we're constrained by the speed of light and how fast information can move through wires, even if we have fiber optic connections. And so this can actually drastically slow down your tests. So the best practice to avoid this is to set up a DMZ proxy in each location, right? So this little curly thing is my attempt at drawing a wormhole. So this is like, you've got 3 different data centers in San Jose, Chicago, and New York with systems under test in each one of these things. You want to set up a DMZ zone with a Sauce Connect server running inside that DMZ zone in each one of these data centers. And that way, when you start a test, everybody knows the desired capabilities object that you can pass from your test along to Sauce Labs. There's a great little key in that desired capabilities called tunnel identifier. And what you can do there is you can say, hey, I'm testing a staging server in Chicago, so I'm going to pass along tunnel identifier Chicago to all of my tests there. And that way, Sauce Labs will be able to route the traffic directly through the right tunnel and avoid these big geographical hops. So another problem here is that we've gone from ephemeral tunnels running all over the place to consolidating all of our tunnels in one place. And nobody here likes single points of failure, right? These are the things that give us nightmares and keep us up at night. And it's true, right? We're introducing a single point of failure here where an individual Sauce Connect process can crash. We've all seen this happens unexpectedly sometimes. Each Sauce Connect process has its own limited bandwidth. It's one process, and if you're squeezing a massive amount of tests concurrently through one single Sauce Connect process, it can choke and slow you down. And there's been cases in the past where long-running Sauce Connect processes can be problematic, where if a Sauce Connect process is running for multiple days, this can lead to instabilities. This is something that I've been working with Sauce Labs on for a long time, and I've been told that this has has been fixed and might not be a problem anymore, but still it's something to be aware of that has been a problem in the past. So a solution for this is to use what Sauce Labs calls high availability mode. And there's a flag that's not exactly intuitive that this is what it means, but it's called no remove colliding tunnels. That means you're dropping into high availability mode when you use this flag to start up Sauce Connect. And what this means is that on a DMZ server, which is this blue box here, instead of just running one Sauce Connect process, you can run many. You can run as many as you want. You could run 2, 4, 8, 30. I think there's limits about how many tunnels you can actually spin up per account. But what you can do with this no remove colliding tunnels flag is you can start up a bunch of tunnels that all have the same ID. So let's say we're running this in Chicago, so we're going to start these all up with the Chicago ID. Now, without this flag that says no remove colliding tunnels, if you start up one tunnel called Chicago, and then a minute later you start up another tunnel called Chicago, Sauce Labs is going to say, whoa, 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 hold on, there's already a tunnel called Chicago. I'm going to nuke that one before I start up the second one. But if you pass this flag, no remove colliding tunnels, it's going to say, oh, OK, we've already got a tunnel called Chicago. I'm going to add it to the pool, to the high availability pool. And Sauce Labs is going to consider these to be logically part of the same tunnel group, which allows you to do some pretty magical things. Now, basically what Sauce Labs does on their side is they have a load balancer where if you have tunnels that are part of the same high availability group, it's going to randomly assign a test that's looking to talk to the Chicago tunnel. It's going to randomly assign it to one of the tunnels that matches that identifier. And so this is nice because it alleviates the load on an individual tunnel. We talked about those capacity issues with how many concurrent tests a single tunnel can process. And this also means that if one tunnel is unstable for some reason, ideally you've set up your tests to retry if there's a problem. And chances are the next time it'll go through a different tunnel which isn't experiencing problems. So it kind of insulates you from a single point of failure of one tunnel process. Now, some of you might be thinking, okay, well, that's great, but these are still all running on one single server, right? So what if that single server goes down, somebody trips over the power cord, then what happens? So luckily, you can expand, you can scale this horizontally, and you could have as many servers as you want that are all using that same Chicago identifier. And we're taking these individual tunnels, grouping them into mega tunnels, and then grouping those mega tunnels into super tunnels. Sauce Labs will seamlessly load balance all of this for you and treat it all as one logical tunnel, even if it's running on 1, 2, 4, 10 different physical machines, which is pretty great. So to get past this issue of instabilities with tunnels that are long-running processes, another best practice that Sauce Labs advertised in the past was rolling restarts. And this basically is something where you manually, with your own scripting, close and reestablish tunnels one at a time, right? So if you have this big high availability pool, you're gonna close one tunnel. When that one's closed, you're going to close another one, and after they're closed, they get restarted. So that way, no one tunnel stays alive for too long. It's important when you're doing the rolling restart to use what's called the wait tunnel shutdown flag. And what this does is that if a test is actually running in one of these tunnels that is flagged for shutdown, instead of just killing the tunnel right away and saying, sorry, test, I guess you're dead now, it's going to wait for that test to finish, and it's going to stop new tests from going into that particular instance of a tunnel. So this allows the tunnel to shut down gracefully without affecting tests. Historically, Sauce Labs recommended to do this on a 24-hour interval. You can use your own judgment if that's something you want to keep doing. We've been told that now Sauce Labs has shown that even tunnel instances running for months at a time have been perfectly rock solid. So this might not be anymore. Right, may not be strictly necessary anymore, disclaimer. All right, so another problem is how to monitor all of this, right? So we heard in the last session a question about, hey, if an individual Sauce Connect process has problems, how do we ever know about it, right? And ideally, none of us want to find out about this because tests start failing massively all of a sudden, and then all the developers start complaining again about how Selenium is flaky and we should just get rid of it. We want to get proactive heads up about this kind of stuff without the tests themselves being the canary. So of course you can write a custom script to check for the presence of tunnel processes and send alerts if they're not present, but maybe by this point you're like, okay, I was with you at first, but this is starting to get way too complicated and I don't want to do all this, so yeah, right? So I've got some good news for you. So as part of Test Armada, we created an open source project called Crowsnest. This has been sponsored and developed at Walmart Labs, and it's been in use for the better part of the last year. And basically all of Walmart's tests are running through Crowsnest now, which is a process that does all the heavy lifting for you of managing and monitoring high availability SOS Connect's tunnel cluster. So here's a little bit about how it works. It has a simple JSON config. You basically just specify your account details, username and access key, the number of tunnels that you want on a particular host, and Crowsnest will handle auto-launching and monitoring the health of each tunnel for you. It'll handle that process of checking to make sure the process is still alive, and if an individual SOS Connect tunnel dies, it will respawn it for you without you even having to do anything. Crowsnest also handles rolling restarts of tunnels at an interval that you specify. You could rolling restart them on an hourly basis, daily, weekly, whatever you want. As I mentioned, this might not be necessary anymore, but if it gives you a little peace of mind, that's something you can do. And for the monitoring piece, Crowsnest will send tunnel uptime and health metrics to a monitoring service of your choice using the StatsD protocol, kind of outside of the scope of this talk, but this is one of my favorite open source projects created by Etsy. Very easy to understand protocol for basically sending any metrics anywhere, and it has a lot of interoperability with open source monitoring solutions. So in practice, this means that you can use an open source data visualization, monitoring graphing tool like Grafana is one of my personal favorites. That's what this example here is, where you can get these nice big dashboards. As Leo mentioned, you can put these, wall mount these in your office if you want. It tells you how many tunnels you have up currently in your high availability cluster, the maximum age that they've been up if you have rolling restarts implemented and you want to make sure that there's no runaway tunnels that have been up for weeks when you expected them to be shut down after a day. And you can also graph them like this, so you can see the rolling restart happening. You can see this is measuring the tunnel uptime, so we can see it's been steadily increasing. Once it hits the 24-hour period, it drops down to 0 because it's been restarted and then keeps climbing again. Another thing that you can do is when you're setting up your dashboards is you can install an agent on the DMZ server itself. One of my personal favorites is called Telegraph, which collects system metrics about CPU, memory, network utilization. This is a great way to make sure that you're not overtaxing the DMZ proxy itself, because you don't want that to be pegged at 100% CPU and maximum network. This is when we were doing a stress test, running a massive amount of concurrency overnight. We stopped at 8 o'clock in the morning, but we were basically checking to see if we were going to max out the capacity of our network card on that box, and we didn't come close, which was great. This is one of my favorite graphs because this shows the uptime of a pool of 10 tunnels running on the same machine, and they create this really trippy effect here. And what we're seeing is that up until 8 o'clock, as I mentioned, we were running this stress test, right? And you remember that with that no tunnel shutdown flag, that if a test is currently running inside a tunnel, and you send it the stop command, it's going to say, okay, cool, I'm going to stop as soon as I'm done running my current test. So what we're seeing is that the latency between rolling restarts is slightly spread out during this period of high usage because the tunnels are taking a few minutes to shut down. But then at 8 o'clock when we stopped our stress tests, everything kind of collapsed into more tight rolling restarts because the tunnels were able to restart pretty much immediately when they were requested to, because nobody was running any tests at the time. So I want to give a shout out to my Test Armada colleague, Lei Zhu, who's the primary developer of Crowsnest, and he works for Walmart. And he ran an experiment because he wanted to prove, hey, not only does this help with our information security, but running everything through a bottleneck of a high availability cluster is not going to actually slow down our test suite. And what we found was exactly the opposite, that running all of our tests through this high availability cluster instead of just single ephemeral tunnels on the build machines themselves actually made the tests run 10 to 15% faster via the DMZ. So we got an unexpected speed boost there. So takeaways from this, please talk to your IT security team. If you don't have that, just talk amongst yourselves at your company about creating a DMZ network. It sounds complicated, but it's really just some extra firewall rules. It doesn't need to be complicated. Plan for the worst, right? Expect the worst, hope for the best. But yeah, don't let a hacker someday ruin your day. And carefully consider each internal host that the DMZ should be allowed to talk to. It adds a little bit of extra burden whenever you want to have Sauce Labs test something new. You'll have to create a firewall rule for it, but you'll have total confidence that you're not opening up your internal network to the kind of hacking that a company like Target got exposed to. Consider using Crowsnest to manage your high availability tunnel setup. We've had a few users on GitHub that have found us, that have started using Crowsnest at their companies and been happy with it. We really want this to be something where we're getting a lot of voices contributing to the development of this. So please give it a try, and if there's something missing, file an issue and let us know. And consider adopting a monitoring solution like StatsD, Grafana, to ensure that your high availability tunnels stay healthy. And again, if you use Crowsnest, you get a lot of this for free. And I'll leave you with one final piece of advice from one of my favorite shows, The X-Files: trust no one. So thank you very much. Yeah, we've got time for questions.
A quick question. I didn't get your monitoring tool. Is a vendor or your Crowsnest have a monitoring tool? Who is a vendor, or like you build that monitoring?
Yeah, I kind of did a lot of hand waving over the monitoring part. So basically, what Crowsnest does is it just sends out some metrics using what's called the StatsD protocol. That it basically sends out some metrics like number of tunnels up equals 5. Tunnel uptime for tunnel instance 3 equals this many milliseconds. Crowsnest has a configuration where you basically tell it in your JSON file where you want it to send that metric data, and it's expecting that you've set up your own infrastructure at a server. Basically, you've set up a StatsD server to receive those metrics. There's a lot of great information about StatsD and metrics and Grafana. I recommend the Etsy engineering blog, Code as Craft. That's where I learned all of this, and that should give you some good starting points. But yeah, if you have trouble setting this up with Crowsnest, we're a friendly bunch with Test Armada, so file an issue or just let us know.
So when you did when you set up multiple connections, is the connection pool or the pooling logic built into Crowsnest, or are you using something specific? Did you sort of roll your own on that one? How'd that work?
So really, the Sauce Labs handles all of the pooling logic on their side. All we handle is basically kind of the scheduling aspect and the process management of starting up a bunch of Sauce Connect processes at an interval and restarting them periodically. But as far as the pooling aspect, all we do is just assign the same tunnel identifier to each instance. And then on the Sauce Labs side, they do the load balancing where they'll send a test matching that tunnel identifier to a random instance of that tunnel. So we really didn't have to do very much pooling logic ourselves.
Do you know offhand if Crowsnest makes use of the, I guess, more recent recommendations of using Upstart and systemd to manage how Sauce Connect gets started?
We do not use those. We're using a process manager called PM2, an open source process manager. I think we'd be open to suggestions if there's a more reliable or better recommended way to do it. But PM2 was a good solution at the time that we did it. All right, thanks so much, everybody. I'll be hanging around, so if you have any more questions, feel free to come talk to me. Thanks.
All right. Excellent.